Alright, we're just cruising along. We're going to go through Chapter 3. Hopefully you'll see that Chapters 1 through 4 are actually pretty small or straightforward. Chapter 3 is definitely in that category as well. We're basically going to go over some basic principles. Those of you who've done testing before, this is intuitive, but we're going to apply some terms to it so we all are talking about the same thing moving forward. Alright. There's two main categories for Chapter 3. We want to talk about the main engineering principles. How in general do we go about working with tests in an engineering environment, and then there's specific testing principles that we want to talk about as well. So the general ones, most of you have done this in programming or even in any design, is usually do divide and conquer. Okay, we have a large object, let's divide it up, or project, let's divide it up in sections and then conquer each one. You want to make sure it's visible, you want to make sure everyone's talking to one another or can see each other. It can be problematic at some point. The third one is unfortunately the one that's probably the most important, that gets left to the wayside a lot: feedback. Basically, if you find an error, you need to come up with a way to prevent the error from popping up again. If a programmer constantly makes this type of programming mistake, you want to somehow help the programmer not do it again. And usually the way you do that is amending to the process, maybe add a code review or a certain static check when someone submits their code. Now, specific to when you're actually doing testing, your first one is sensitivity. Basically, if a test tests for something, aka divide by zero, you want to make sure that's always able to tell you if you have a divide by zero problem. You don't want it to sometimes run the test and it doesn't work, and other times it does detect it. You want it to always detect it. And now, divide by zero, you might think, okay, well, that's obvious. It should always detect that, but it could actually be difficult if you start testing for race conditions, for example, in multi-core systems, and that can be a little problematic. But that's why sensitivity is important. You want to make sure that every time you run the test, if your full regression suite completes, you will know that you have basically checked off on a bunch of different types of check: divide by zero, maybe some race conditions, etc., etc. Redundancy is important. While it's annoying trying to test for the same thing twice, it's also good defense in depth. Maybe you want to test for something at one level and then test for it again later on. Something may change in different layers. Maybe when you're at the high level, the error does present itself, but the low level, no one sees it because it hasn't been connected together. And then restrictions, just making the problem easier. We'll get to that in a moment. So back to the specific examples, they talk about sensitivity. Really, this is just make sure your test cases, if you're testing for something in particular, it always tests for it thoroughly and will tell you whether it happened or not. Redundant, definitely want to have checks increase the capabilities of catching it. So you may have something on the static typing. You could have something on the validation of specification. You have to keep in mind when we're talking about redundancy here, it's not just unit test cases. It's also someone going in and maybe inspecting the specification or looking at the model that you may have come up with. So there's different aspects that you can test for. Obviously, from a software standpoint, you can do unit test and also have that same test in the subsystem test so that you can see if everything works when it's put together. It's a redundant test per se, but it is helpful when you look at it from more than one perspective because it'll give you it just gives you more confidence that something is working. All right, partitioning. Back to general idea, divide and conquer. Hopefully we're all used to this. This is very common. You get the requirements, you come up with a spec, and then you have subsystem specs, and you just divide it on down until someone can manage a piece of code, and then you have that engineer work on it. All right, so here's a restriction. So suitable restrictions can make hard problems a lot simpler. So weak spec may be easier to check. It's impossible in general to show that pointers are correctly used. But in Java, that pointers are initialized before use is simply enforced. In other words, that's a good example. In C++, pointers are never initialized. In Java, a pointer is. Now, some of you may say Java doesn't have pointers. What he's talking about is references. Whenever you have an object, it's implicitly set to null when it starts, unless you actually create the object. That pointer, that is a pointer in Java. So Java actually simplifies or restricts the problem by adding a restriction. Maybe you could enforce this in C++, for example, is when you have a pointer, you can only get a pointer by calling some function, and that function just makes sure that it is started off as null. And then you would have a static analysis at some point that would make sure that whenever someone creates a pointer, it uses your function call. Definitely more complicated, but would hopefully satisfy the same requirement. So visibility, you want to just make sure that you present not only what you're doing with other engineers, but you want to send it up to the business person. Remember, the point of a lot of testing and the point of the software engineering process is to make it so that not only you can have can quickly produce software code, but it also allows the business people to basically not bother you, because hopefully the process presents them with the tools necessary in order to get the information they want. So you might be able to have a process that you hook into a Scrum right now. Scrum Agile is pretty popular, and you just basically run off tell you when a subtask is done inside of Jira, and when that happens, that will eventually that'll be tracked in Jira, and if the business person wants to run a report, they can see how many of your subtasks have you completed. And a lot of times that's all they want. They just want to know, okay, we're making progress. All right, we're making progress. Great. What's the progress? Okay, you got maybe 7 of the 15 done in 2 days. Okay, great. Hopefully, maybe we'll get it done at the end of the week, or it might spill into next week. That's really what they want to know. They understand, I should say, any good business person understands that sometimes when you're doing engineering, you're going to hit a roadblock until you can knock it out. But you want to give some visibility to everyone. So you need to be observable. Also, again, with the Jira example, if you have the actual setup right, when you submit your code to the repository, you can actually put the tag in, and Jira could, if you set it up right, automatically know that this submission completes a subtask, and you can move on from there. All right, feedback. Let's say you're constantly having this pointer issue that we talked about beforehand. Maybe come up with another, maybe you could add something to the static analysis when they submit their code to see if they are actually initializing all their pointers to null. And that would be something in the process, because before you could submit your code to the main repository, it would go through a code review that could do automatic static analysis. And that's part of the process. And that's actually a simple process that doesn't get in the way too much, because it should give the programmer nearly instant feedback. I think one issue most people have is they think the process slows them down, and a lot of processes do, but that does not have to be the case. All right, so we talked about basically 6 different terminologies. Sensitivity, aka consistency, is what I like to really call it. You want to make sure that your test always checks for something correctly. Redundancy, it's best to check for something at multiple different levels. That gives you more confidence in that it's working correctly. Restriction, you want to make the problem easier. That was the pointer example. Partition, very common, divide and conquer. Visibility, you want to make sure that not only other engineers know where you are and how much you've completed, but you want to also make sure that the business people know how far you're along, because they have schedules they have to report up the chain and figure out what's going on. And then feedback. Feedback, this is really something that I think engineers need to work more on. If you provide the right feedback to business people, you can simplify the process and make everyone happier. All right, that's all for Chapter 3. And yep.